The ventromedial frontal cortex is a part of the frontal cortex in the mammalian brain. The ventral medial frontal is located in the frontal lobe at the bottom of the cerebral hemispheres and is implicated in the processing of risk and fear. It also plays a role in the inhibition of emotional responses, and in the process of decision-making. Anatomy: while the ventromedial frontal cortex does not have a universally agreed-on demarcation, in most sources, it is equivalent to the ventromedial reward network of Unger and Price. This network includes Brodmann Area 10, Brodmann Area 14, Brodmann Area 25, and Brodmann Area 32, as well as portions of Brodmann Area 11, Brodmann Area 12, and Brodmann Area 13. However, not all sources agree on the boundaries of the area. Different researchers use the term ventromedial frontal cortex differently. Sometimes, the term is saved for the area above the medial orbitofrontal cortex, while at other times, ventromedial frontal cortex is used to describe a broad area in the lower central region of the frontal cortex, of which the medial orbitofrontal cortex constitutes the lowermost part. This latter, broader area, corresponds to the area damaged in patients with decision-making impairments investigated by Anticube Nyodamas and colleagues. To get a rough idea of where the ventromedial frontal cortex is, recall that the left and right hemispheres of the brain are separated by the longitudinal cerebral fissure. Now imagine you could take your hand and, starting at the anterior brain, insert it into this gap until you reach the insula. Your palm would be touching a part of the frontal cortex, which is in the front part of the brain, and the lower part of your palm would be touching the ventral medial frontal cortex. The ventromedial frontal cortex is connected to and receives input from the ventral tegmental area, amygdala, the temporal lobe, the olfactory system, and the dorsomedial thalamus. It, in turn, sends signals to many different brain regions including the temporal lobe, amygdala, the lateral hypothalamus, the hippocampal formation, the cingulate cortex, and certain other regions of the frontal cortex. This huge network of connections affords the VMPFC the ability to receive and monitor large amounts of sensory data and to affect and influence a plethora of other brain regions, particularly the amygdala. Function: functional differences between the orbitofrontal and ventromedial areas of the prefrontal cortex have not yet been clearly established, although the areas of the ventromedial cortex superior to the orbitofrontal cortex are much less associated with social functions and more with pure emotion regulation. Research in developmental neuroscience also suggested that neural networks in the ventromedial frontal cortex are rapidly developing during adolescence and young adulthood, supporting emotion regulation through the amygdala, being associated with a decrease in cortisol levels. There are only a few reports of people with early-onset VMPFC damage during childhood, but these individuals tend to have severe antisocial behavior and impaired moral judgment. Compared to individuals with damage later in life, their behavior pattern is similar but more severe. Decision-making patients with bilateral lesions of the VMPFC develop severe impairments in personal and social decision-making even though most of their intellectual ability is preserved. For instance, they have difficulties in choosing between options with uncertain outcomes, whether the uncertainty is in the form of a risk or of an ambiguity. After their lesion, these patients have an impaired capacity to learn from their mistakes, making the same decisions again and again even though they lead to negative consequences. These patients choose alternatives that give immediate rewards, but seem to be blind to the future consequences of their actions. However, the underlying mechanisms of this behavior are not yet fully understood. Damage to the ventromedial frontal cortex has been connected with deficits in detecting irony, sarcasm, and deception. Subjects with damage in this area have been found to be more easily influenced by misleading advertising. This has been attributed to a disruption of a false tagging mechanism, which provides doubt and skepticism of new beliefs. People with damage to the ventromedial frontal cortex still retain the ability to consciously make moral judgments without error, but only in hypothetical situations presented to them. There is a gap in reasoning when applying the same moral principles to similar situations in their own lives. The result is that people make decisions that are inconsistent with their self-professed moral values. People with early damage to the ventromedial frontal cortex are more likely to endorse self-serving actions that break moral rules or cause harm to others. This is especially true for patients whose damage occurred the earliest in life. Emotions and an understanding of social norms are used to provide reasoning of the moral nature on our behaviors, beliefs, and the people around us. The VMPFC works as the neural basis in allowing emotion to influence moral judgment. The Trolley Dilemma is a classic situation testing emotional involvement in moral judgment. In the Trolley Dilemma, participants imagine a runaway trolley heading toward 5 people who will be killed if the trolley is to continue. The participant is to decide whether to allow the trolley to run its course, or to shunt the trolley off to another track where it will only kill 1 person. Most people choose to throw the switch, concluding that it is moral to save 5 by sacrificing the life of 1. In a variation, there is no switch at hand to shunt the trolley. Instead, the participant has the option to push someone on the trolley tracks to stop it from moving. Most people are repulsed at the idea of pushing the man to his death, even though outcome is the same as the first dilemma, with 5 people surviving and 1 person dying. The more personal the nature of pushing someone onto the tracks discourages this response, and the role of emotion is proposed to be the difference in the reasoning. In functional imaging studies, increased activity in the VMPFC is associated with thinking of these personal moral situations, while making harmless decisions does not. Patients with VMPFC lesions made the same decision in non-moral and moral personal dilemmas. Dysfunction of the VMPFC causes failure in using correct moral emotion, which explains why these patients showed less emotional responses when facing these dilemmas. Regulation of emotion the VMPFC plays an important role in regulating and inhibiting our response to emotions. VMPFC seems to use our emotional reactions to model our behavior and control emotional reactions in certain social situations. The inputs of the VMPFC provide it with information from the environment and the plans of the frontal lobe, and its outputs allow the VMPFC to control different physiological responses and behaviors. The role of the VMPFC is especially highlighted in people with damage to this region. A damaged VMPFC causes impairments of behavioral control and decision-making, consequences which are rooted in emotional dysregulation. The first and most famous case of someone with defects to this region was Phineas Gage, a railroad construction foreman who in an accident 1848, had his VMPFC bilaterally destroyed. Before his accident, Gage was described as a serious, industrious and energetic. Afterward he became childish, irresponsible, and thoughtless of others. Another patient with VMPFC damage wasted away his life savings on foolish investments and failed to make appropriate decisions in his personal life. In patients with VMPFC damage, evidence shows that there is a correlation between emotional dysregulation and dysfunction in real-world competencies. The amygdala plays a significant role in instigating the emotional reactions associated with anger and violence. With the VMPFC unregistered trademark S outputs to the amygdala, the VMPFC plays a part in preventing such behavior. Evidence has shown that impulsive murderers have decreased activity in the frontal cortex and increased activity in subcortical areas such as the amygdala. This imbalance can enhance actions that are created by negative emotions and limit the ability of the frontal cortex to control these emotions. Lower activation in the frontal cortex is also correlated with antisocial behavior. The dysfunction of the ventromedial cortex seem to, in part, be caused by lower levels of serotonin release. The VMPFC also is involved in courage. In experiments with participants allowing snakes to come near or away from them, acts of courage correlated with activation in the VMPFC, specifically the subgenual anterior cingulate cortex. Activation of the VMPFC is associated with successful suppression of emotional responses to a negative emotional signal. Patients with VMPFC lesions showed effects both in emotional response and emotion regulation. Their emotional responsivity is generally diminished and they show markedly reduced social emotions such as compassion, shame and guilt. These are emotions that are closely associated with moral values. Patients also exhibit poorly regulated anger and frustration tolerance in certain circumstances. Patients with focal lesions in the VMPFC show personality changes such as lack of empathy, irresponsibility, and poor decision-making. These traits are similar to psychopathic personality traits. The right half of the ventromedial frontal cortex was associated with regulating the interaction of cognition and affect in the production of empathic responses. Hedonic responses were also associations to orbitofrontal cortex activity level by Morton Krinchelbach. This finding contributes findings suggesting ventromedial frontal cortex being associated with preference judgment, possibly assigning the ventromedial frontal cortex a key role in constructing oneself. Studies with PTSD also supported the idea that the ventromedial frontal cortex is an important component for reactivating past emotional associations and events, therefore essentially mediating pathogenesis of PTSD. Treatments geared to the activation of the ventromedial frontal cortex were therefore suggested for PTSD. The right half of the ventrolateral frontal cortex, being active during emotion regulation, was activated when participants were offered an unfair offer in a scenario. Specific deficits in reversal learning and decision-making have led to the hypothesis that the ventromedial frontal cortex is a major locus of dysfunction in the mild stages of the behavioral variant of frontotemporal dementia. The capacity for mature defense mechanisms such as intellectualization, compensation, reaction formation, and isolation has been tied to proper functioning of the right ventromedial frontal cortex, while more primitive defense mechanisms such as projection, splitting, verbal denial, and fantasy have been found to rely on other regions, primarily in the left hemisphere. Somatic marker hypothesis One particularly notable theory of VMPFC function is the somatic marker hypothesis, accredited to Anticube Nyodama Sayo. By this hypothesis, the VMPFC has a central role in adapting somatic markers emotional associations, or associations between mental objects and visceral feedback for use in natural decision-making. This account also gives the VMPFC a role in moderating emotions and emotional reactions because whether the VMPFC decides the markers are positive or negative affects the appropriate response in a particular situation. However, a critical review of this hypothesis concluded that there is a need for additional empirical data to support the somatic marker theory. Extinction Another role that the VMPFC plays is in the process of extinction, the gradual weakening and eventual cessation of a conditioned response. The specific role played by the VMPFC concerning extinction is not well understood, but it is believed that it plays a necessary role in the recall of extinction learning after a long period of time. Studies show that it aids in the consolidation of extinction learning. A separate study has implicated the correlation between the cortical thickness of the VMPFC and the degree of extinction memory. Patients with larger VMPFCs tended to have lower responses to the extinct conditioned stimulus, therefore suggesting a superior extinction memory. In general, the ventromedial frontal cortex plays a major role in the later stages of memory consolidation. Gender-specific social cues Ventromedial frontal cortex lesions were also associated with a deficit in processing gender-specific social cues. One experiment tested the ability of patients with VMPFC lesions to categorize gender-specific names, attributes, and attitudes compared to patients with dorsolateral frontal cortex lesions and control subjects. Whereas the patients with dorsolateral frontal cortex lesions performed similarly to the control subjects on tests indicating gender stereotypes, patients with ventromedial frontal cortex lesions demonstrated impaired stereotypic social knowledge. Cocaine abuse Frequent cocaine users have been shown to have lower than normal activity in the ventromedial frontal cortex. When asked to perform certain tasks that rely heavily on activation of this area of the brain, the cocaine users perform worse and have less frontal cortex activation than the control subjects. The quantity of cocaine used was found to be inversely proportional to the level of activation. The frontal cortex is also physically affected by cocaine use. Chronic use has been shown to lead to a decrease in the amount of gray matter in the ventromedial frontal cortex. The decrease in gray matter and effect on behavior is analogous to a person having lesions throughout their medial frontal cortex. Specifically, the pyramidal cells of the ventromedial frontal cortex are known to be linked with drug-seeking behaviors. Both an increased and decreased level of activity in these pyramidal cells has shown to lead to extinction of cocaine-seeking behaviors depending on when the activation takes place. An activation of these cells was needed to inhibit cocaine-seeking behavior after a longer duration of time, whereas activation was required to reduce the behavior soon after using cocaine. References. External links: The Brain from Top to Bottom, Brain Abnormalities Associated with Anxiety Disorders, Becheria, Traynor D., Damasio H. Characterization of the decision-making deficit of patients with ventromedial frontal cortex lesions. Brain 123, 2189 Euro 202 doi, 10.1093123.11.2189. PMID 11050020. Quirk G. J., Russo G. K., Barron J. L., Lebron K. The Role of Ventromedial Frontal Cortex in the Recovery of Extinguished Fear. J. Neurosci. 20, 6225 Euro 31. PMID 10934272. Scientists draw link between morality and brain's wiring. Wall Street Journal, May 11, 2007. Carey, Benedict. Brain injury said to affect moral choices. New York Times. Shamatsuri, S.G. Toma, R. Berger, B.D. A Hare and Parrots, J. Characterization of empathy deficits following frontal brain damage, the role of the right ventromedial frontal cortex. Journal of Cognitive Neuroscience 15, 324 Euro 37 doi, 10.1162/089892903321593063. PMID 12729486. Hooper C.J., Luciana M., Conklin H.M., Yarger R.S. Adolescence Performance on the Iowa Gambling Task, Implications for the Development of Decision-Making and Ventromedial Frontal Cortex. DevPsychol 40, 1148 Euro 58 doi, 10.1037/012-1649.40.6.1148. PMID 15535763. Elliott R., Rees G., Dolan R. J. Ventromedial frontal cortex mediates guessing. Neuropsychologia 37, 403 Euro 11 doi, 10.1016 per second 0028-3932, 98, 00107-9. PMID 10215087. Rahman, S. Sahakian, B. J. Hodges, J. R. Rogers, R. D. Robbins, T. W. Specific cognitive deficits in mild frontal variant frontotemporal dementia. Brain 122, 1469 Euro 93 doi, 10.1093122.8.1469. PMID 10430832. Jacques Myler. Susanna Frank. Cognition on Cognition. MIT Press pages 3 Euro. ISBN 978-0-262-63167-9. Intensity to Future Consequences Following Damage to Human Frontal Cortex. Uri Hill, Van Oekum C.M., Johnston T., A.L. Amygdala and ventromedial frontal cortex are inversely coupled during regulation of negative affect and predict the diurnal pattern of cortisol secretion among older adults. J. Neurosci. 26, 4415 Euro 25 doi, 10.1523/Shirossi 3215-05.2006. PMID 16624961. Paulus M.P., Frank L.R. Ventromedial frontal cortex activation is critical for preference judgments. Neuro Report 14, 1311 Euro 5 doi, 10.1097/011WNR000785430.07662.02. PMID 12876463. Zord DH, Matz and Dale, Pardo JV. Brain activity in ventromedial frontal cortex correlates with individual differences in negative effect. Proc. Natal. Accord. Sci. USA 99, 2450 Euro 4 doi, 10.1073/FNAS 0424571999. PMC 122385. PMID 11842195. Tobin G, Satput AB, Lieberman MD. The Sunny Side of Fairness, Preference for Fairness activates reward circuitry. Psychol Sci 19, 339 Euro 47 doi, 10.1111 per joule 1467-9280.2008.02091x. PMID 18,399,886. The orbitofrontal cortex, linking reward to hedonic experience, Milne E., Grafman J. Ventromedial frontal cortex lesions in humans eliminate implicit gender stereotyping. J. Neurosi. 21, RC 150. PMID 11,404,442. Koenigs M., Huey D., Raymond 5, AL focal brain damage protects against post-traumatic stress disorder in combat veterans. Nat. Neurosi. 11, 232 Euro 7 doi, 10.1038/NN 2032. PMC 2,693,133. PMID 18,157,125. Sanchez Navarro, Juan P. Driscoll, David. Buchanan, Tony W. Becerra, Antoine. Anderson, Stephen W. Trainell, Daniel. Ventromedial frontal cortex regulation of propulse inhibition and emotional modulation of the startle reflex, effective lesion onset. Front. Hum. Neurosi. Conference Abstract, 11 International Conference on Cognitive Neuroscience. doi, 10.3389/conf/FNHUM. 2011.207.00165.